As you might know, space is full of surprises. We explore the cosmos expecting to find strange and wonderful things, but some discoveries still make us scratch our heads, like asteroids that look like watermelons. Yes, you read that right. Out there, amidst the stars and galaxies, float celestial objects resembling giant, spacefaring fruits. These aren't your average lumpy asteroids. They have a distinct, elongated shape, rounded at the ends and cinched in the middle, just like their namesake. It's a bizarre phenomenon that has puzzled scientists for years. So why do some asteroids look like watermelons? The answer lies in how they spin and the forces acting on them. When an asteroid spins fast, it can stretch out and take on this unusual shape. It's a mix of physics and cosmic coincidence. For a long time we thought of asteroids as just simple rocks flying through space, leftovers from when the solar system was formed, just bits of cosmic debris. But as we've studied them more, we've found that asteroids are much more interesting. They come in all sorts of shapes and sizes, from tiny potato-like pebbles to huge round giants. Their makeup is also very different. Some are mostly rock, others are full of metals, and some even have water ice. This variety tells a story of crashes, gravity, and billions of years of space history. Among these space rocks, the ones shaped like watermelons are especially mysterious. Their strange shapes give us hints about the forces that shape them over time. Let's look at two fascinating asteroids, Dimorphos and Selam. Dimorphos is a small moon orbiting a bigger asteroid called Didymos. In 2022, NASA crashed a spacecraft into Dimorphos. This was part of the DART mission, the first test to see if we can change an asteroid's path. Selam is a smaller asteroid located in the main asteroid belt between Mars and Jupiter. Both Dimorphos and Selam have a unique shape that looks like a watermelon. Imagine you're a space detective looking into the vast universe. Your mission is to find out why some asteroids look like watermelons. Like any detective, you need clues. But how do you study something so far away? That's where astronomers get creative. They use telescopes and computer simulations to gather clues from light. Telescopes on Earth and in space capture light from these asteroids. By studying this light, we learn about their makeup, spin, and shape. Space missions like the DART mission give us close-up views of asteroids. With computer models, we can test how different forces shape these asteroids over time. Section 2. The Spin Doctors: How Rotation Shapes Asteroids. An asteroid's shape is greatly influenced by how fast it spins. Think of it like a spinning top. Asteroids also rotate on their axis. But unlike a top, their spin can change due to collisions or the pull of nearby planets and stars. This spinning isn't just for show, it actually helps shape the asteroid. As an asteroid spins, the material near its middle gets pushed outward by centrifugal force. The faster it spins, the stronger this force becomes. If it spins really fast, this force can make the asteroid bulge at the middle, giving it a shape like a watermelon. This effect is more noticeable in smaller asteroids because they have weaker gravity, making them easier to deform. Section 3. Gravity's gentle touch: shaping from within. It's not just spinning that shapes asteroids. Gravity, the force that holds the universe together, also helps mold these space rocks. Asteroids are like big piles of rubble, loosely held together by their own weak gravity. Over time, gravity makes the asteroid settle and compact, giving it a more stretched out shape. Imagine a giant sandcastle in space. At first, the sand is loose, but gravity pulls it down, making it more compact and defined. This process, called gravitational collapse, is key for asteroids made of many small pieces. These asteroids are like jigsaw puzzles of smaller rocks, not one solid piece. The constant movement and settling of these pieces driven by gravity give asteroids their unique shapes. Section 4. A history of violence, impacts, and their mark. Collisions are key in shaping asteroids. The solar system is like a giant shooting gallery, with asteroids showing marks from many hits. These hits can be small bumps or huge smash-ups. Big impacts can break asteroids apart, which then come back together in new shapes. Smaller hits make craters and dents. Tiny micrometeoroids slowly wear down and shape asteroids over time. Let's dive into the heart of an asteroid. Ever wondered what's inside these space rocks? Many asteroids, like Dimorphos, aren't solid rock. Picture a giant pile of rubble, with rocks of all sizes held together by gravity. These are called rubble pile asteroids. Imagine a loose collection of rocks spinning in space. They stretch out at the equator as they spin. Like a merry-go-round, things fly outward. But here, it's rocks, dust, and maybe even ice. This explains why some asteroids look like watermelons. Weaker gravity makes it easier for them to stretch out as they spin. Spin rate, a delicate balancing act. Not all spinning asteroids look like watermelons. The speed of their spin is very important. If an asteroid spins too slowly, it stays lumpy and irregular. If it spins too fast, it can break apart. There's a perfect spin speed that helps it become watermelon-shaped. Imagine a figure skater spinning. When they pull their arms in, they spin faster. Asteroids work the same way. Over billions of years, collisions or gravity from a nearby planet can change an asteroid's spin. As it spins faster, material moves to the middle, making it look like a watermelon. Cosmic Play-Doh, the role of material. Spin rate is just one part of the story. What an asteroid is made of also matters. Like Play-Doh is easier to mold than a rock. Some asteroid materials are more flexible. Asteroids with lots of carbon or ice are less stiff. They can change shape more easily, making them look like cosmic watermelons. Rocky asteroids are tougher. They can spin fast without changing shape. It's like trying to mold a watermelon out of granite. If a rocky asteroid looks like a watermelon, it might have spun really fast or had a big collision in the past. Collisions in space are like nature's sculptors, shaping asteroids over time. These impacts can break apart asteroids, but they also help form new ones. A big collision can create a cloud of debris that eventually forms a new asteroid. Smaller hits leave craters and grooves, adding to the asteroid's unique look. Each impact is like a tiny chisel, slowly carving the asteroid's final shape. These space rocks, which look like watermelons, teach us how to protect Earth. Remember Dimorphos? NASA's DART mission aimed at it. Knowing its shape and what it's made of was key to moving it. It turns out Dimorphos is like a pile of rubble, which affected the mission. Imagine hitting a target that's not solid, but like a loosely packed snowball. The impact sends debris flying, creating a recoil that helps push the asteroid. This helped scientists adjust the DART impact to change Dimorphos's path more effectively. This info is crucial for planning how to protect Earth from asteroids. By understanding asteroids better, we can find better ways to deflect them and keep our planet safe. These watermelon-shaped asteroids might be very important for future space missions. Some of them have lots of water ice, which is crucial for long space trips. Imagine them as space gas stations where we can refuel and get supplies without bringing everything from Earth. Water ice can be turned into hydrogen and oxygen, which can be used as rocket fuel or to make air for astronauts to breathe. Since it takes a lot of energy to leave Earth, getting resources from asteroids could make space travel cheaper. These cosmic watermelons, once just interesting objects, could help us explore the solar system. Section 3. Unveiling the past. What asteroids tell us about solar system history. These strange-looking asteroids aren't just interesting for the future, they also give us clues about our solar system's ancient past. Their shapes and materials are like fingerprints, showing evidence of crashes, gravity pulls, and other events that have shaped our space neighborhood over billions of years. By studying these cosmic watermelons, we can learn about the history of the asteroid belt, the area between Mars and Jupiter where most asteroids are found. We can discover what conditions were like in the early solar system, when planets were forming and asteroids were crashing into each other, creating the space scene we see today. Each watermelon-shaped asteroid with its unique story helps us understand how our cosmic home came to be. Section 4. The Unknown Depths. Challenges and Surprises. We've learned a lot about these cosmic watermelons, but the universe always has more surprises. Studying these asteroids up close is tough. Their weak gravity makes landing and moving around tricky. They are like big piles of gravel, so we can't predict how they'll act when touched. Imagine landing on a giant pile of gravel, where the ground could move under you at any moment. But these challenges also bring chances to learn. By studying how these asteroids behave and how they react to impacts, we learn more about the forces that shape our universe. As we explore space, these cosmic watermelons will keep surprising and challenging us, revealing secrets of our solar system and beyond. Cosmic watermelons, a slice of the universe's wonders. Space is full of surprises. We send probes far out into space and use telescopes to look at distant galaxies. Among all this, we find asteroids that look like watermelons. These cosmic watermelons are not just odd shapes, they help us learn about space. Their shapes are made by gravity and time, showing us that space is always changing. From galaxy spirals to asteroid shapes, everything we see today is from billions of years of change. It's a grand dance of matter and energy that amazes us. Let's talk about the future of planetary defense and space resources. Studying these cosmic watermelons isn't just for fun. It has real-world benefits. Knowing their structure and makeup helps us create ways to protect Earth from asteroid impacts. Imagine if we could push a dangerous asteroid away, avoiding a big disaster. The information we get from studying these space rocks makes this possible. And as we explore space more, these asteroids could be very useful. They might have lots of water ice that can fuel our spaceships and provide water for astronauts, helping us live and work in space for a long time. The importance of these space rocks goes beyond their practical uses. They are like time machines, holding clues about our solar system's wild history. Each crater and groove tells a story of ancient crashes, gravity pulls, and the powerful forces that shaped our space neighborhood over billions of years. By studying their shapes and orbits, we can piece together the history of the asteroid belt, a huge ring of rocks orbiting the Sun between Mars and Jupiter. We can learn about what the early solar system was like, when planets were forming and asteroids were crashing into each other. These space rocks give us a peek into our own origins, showing us the swirling cloud of gas and dust that became our solar system. The adventure continues. Embracing the unknowns of the cosmos. Studying these space rocks often leads to more questions than answers. Each mission uncovers new mysteries, expanding our knowledge. How do these loose rock asteroids keep their shapes? What secrets are hidden beneath their surfaces? What surprises await us in the asteroid belt and beyond? These questions drive us to keep exploring. The universe is vast and full of wonders. Our journey of discovery is just beginning. As Carl Sagan said, somewhere something incredible is waiting to be known. Let's keep exploring and marveling at the universe's wonders.